Electron beam is used in a electron microscope when accelerated by a voltage of 20 kilovolt has a de-Broglie wavelength of lambda naught. If the voltage is increased to 40 kilovolt, then the de-Broglie wavelength associated with the electron beam would be 1. 3 lambda naught, 2. 9 lambda naught, 3. Lambda naught by 2 and 4 lambda naught by root 2. So we know the formula kinetic energy is equal to EV when electron is accelerated through a potential difference V. So here we can write lambda is equal to h by root 2 m kinetic energy. Instead we can write h by root 2 m EV. Here h, m and e are all are constants. So we can have a relation. Lambda is inversely proportional to root of potential. So we are asked to find the de-Broglie wavelength after voltage is increased to 40 kilovolt. So let that be lambda, and the before one is lambda naught. So we can write, since it is inverse relation, we will have lambda 1 by lambda 2 is equal to root of T2 V2 by root of V1. So here we will take the initial one's voltage, which is 20, by, since it's a ratio, we not to take the kilo, and the final one's voltage, which is 40. We can whole root it and we'll get 20 by 40. We can cancel, we get 2. So we have 1 by 2. Now we can take this lambda naught to this side and we'll have lambda is equal to lambda naught by root 2, which is our answer, lambda naught by root 2, option 4.